In this video, I'll be talking about Laplace transform. We are going to look at one example, how we use Laplace transform to solve examples. Amen. Okay, let's consider Laplace transform. Sorry, this marker is not working. Okay. Okay, Laplace transform. Laplace transform. Amen. Okay. Yeah. Let's first define what Laplace transform is all about. Mathematically, Laplace transform is defined as Laplace of f of t, amen, is equals to integral 0 to infinity exponential minus st f of t times the t. Amen. This is the mathematical definition of Laplace transform. So let us use this definition to simplify or find one example. Okay, example, find the Laplace transform. Find the Laplace transform of t raised to the power of n. Amen. Okay. So how can we find the Laplace transform of t raised to the power of n? That is what we want to look at. Okay. Please make sure you subscribe and share this video to anybody that is finding it difficult. Thank you and God bless you. Okay, let's look at this idiot. Amen. How can we obtain the Laplace transform of t raised to the powers of n? First, let us define what Laplace transform is all about. We write solution. Amen. Solution. Laplace transform. You know that Laplace transform of this is equals to this. So now Laplace of t raised to the power n is equals to integral 0 to infinity exponential minus st, since our f of t here is t raised to the power what? N. T raised to the power n times the t. Okay? So now what we need to do, I know Laplace transform is not difficult. What you need to know is your integration, most especially integration by parts, and also substitution. Okay, here we are going to use substitution to find the Laplace transform of t raised to the powers of n. Amen? Just listen and follow me. Okay? So how can we obtain this? We now say, since we have exponential minus st, we now let s equals to st. So we are going to make t the subject of the formula. But before we make t the subject of the formula, let us differentiate this function with respect to t. Amen? So if we differentiate s equals to st with respect to t, our ds all over dt, we are going to have s, true or false? Then if you agree with me, dt will now be equals to ds all over s, isn't it? That is, if you cross multiply, you make, okay, for the sake of manias, let's do it this way. Amen? Okay, for the sake of manias. Okay, let's do it this way. If we cross multiply, we'll have ds is equals to s dt, true or false? Then make dt the subject of the formula. It implies that our dt is going to be equals to ds all over what? S, true or false? Okay? Then, so you agree with me, right? Then let us make t the subject of the formula here. S equals to st. So if we make t the subject of the formula, It means our t is equals to what? S all over x all over s. True or false? So now at this point, we now go back to the integral. Where you know that the integral, we have inside the integral exponential minus st, t raised to the power of n, dt. True or false? So we want to substitute in t. We want to substitute anywhere we see t, we substitute in this and the t with this. That is what we want to do. Amen? So let's do it together. Listen very carefully. Okay, let's do it together. So if you agree with me, it implies that the integral will now be of this form. The integral will now be of this form. Integral, this is equals to exponential. You know that you said let x equals to st. So instead of st, we are going to write x minus x. Then t. Note that t is carrying power of n. T, you said t equals to the what? X all over s. So times x all over s. But note that t carries powers of n. Amen. Raised to the power n. Then the t here is this. The t is equals to the s all over s. So times the s all over what? S. You see that the substitution we use here to substitute in for what? T. Do you agree with me? Okay. So if you agree with me, it implies that there is something I want us to know. Amen? Let's go back to our indices, our elementary mathematics, where if we have a raised all over b raised to the power of 2, this implies that this is the same thing as a raised to the power 2 all over b raised to the power 2. True or false? I'm doing this because of something I'm saying here. If you can see what I am saying. Amen? Okay. So if you agree with me, it implies that inside this integral, we are going to have it in this form. Sorry. Okay. Integral 0 to infinity exponential minus s dot x raised to the power of n. True or false? Then s raised to the power n dot this is the same thing as 1 all over s dot ds. True or false? Okay? So if you agree with me, look at this. Look at this. You discover that the base here is s. The base here is s. It means we will still apply indices. True or false? True or false? It's true. So we will apply indices. Which law? We are going to apply multiplication law. True or false? That is, if we have s raised to the power n dot s, this implies that this is the same as s raised to the power n plus what? 1. True or false? Okay? So if you agree with me, this implies that our integral will now be equals to integral 0 to what? Infinity exponential minus x times s raised to the power of n all over s raised to the power of n plus 1 times dx, isn't it? So now, if you can see what I am saying, we can rewrite this idiot. Since this is 1 all over, this is just like this in the integral, 1 all over s raised to the power of n plus 1. True or false? So it's a constant, so we can bring it out. So if we bring it out, s raised to the power of n plus 1 integral 0 to infinity. This is how the integral will looks like. Raised to the power n. Yes. Amen. Okay? So you see that we are almost there. Yes, we are almost there. So if you can see what I am saying, this integral, we are going to write something here. We will take note. Note that gamma of n plus 1 is equals to integral 0 to infinity exponential minus x raised to the power of n dx. Amen? So, if you agree with me, okay, if you agree with me, this implies that instead of this integral, we are going to write this. So now our Laplace transform of t raised to the powers of n is equals to 1 all over s raised to the powers of n plus 1 times, supposed to be this integral, true of us. But we said this integral is the same thing as gamma of n plus 1. So we write gamma of times n plus 1. But also note, amen, note that, okay? Oh, can I clean this part? Okay? Can I clean this part, right? It's okay. Also note that gamma, note that gamma of n plus 1 is equals to what? N factorial. Amen? So our Laplace of t raised to the powers of n is equals to 1 all over s raised to the powers of n plus 1 times n factorial. Then, which is the same thing as, this is the same thing as. Therefore, our Laplace of t raised to the power n is equals to n factorial all over s raised to the powers of n plus 1. This is the final answer. And this is how you are going to solve this type of problem. Thank you and God bless you.